Good morning, guys. Um, Welcome to 1.7. So last night was yesterday afternoon. You looked up some important theorems, and I'm going to talk about those theorems and show you how we can use those theorems in a two-column proof. We're going to be focusing a lot on proofs today. So we're going to be needing these theorems because these are going to be reasons for all of our statements. The first theorem we're looking at is the vertical angles theorem. The vertical angles theorem says that if I have two lines that cross, like you see here, or like you see here, then their vertical angles are congruent. For example, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So if you look at the image, you see that this is 120, and this is 120, and this is 60, this is 60. And of course, I can move these around, and you can see that the vertical angles theorem holds true no matter what the angles are. Okay, so let's look at a two-column proof using the vertical angles. This is your first proof you're looking at. So a theorem is just a conjecture that is proven. Okay, so we're looking to prove conjectures. So we're looking to prove the vertical angles theorem. Now, in order to prove the vertical angles theorem, we're not allowed to use the vertical angles theorem. We're trying to prove it. Okay? In a proof, you're going to be given something, and then you're going to ask to prove something. So here, we're given that angles 1 and angle 2 are vertical angles, and we're trying to prove that angle 1 and angle 2 are congruent. Okay? So let's look at a proof. In a proof, we're looking to make a convincing argument. So in this particular case, we're looking at a two-column proof, which on our left, you're going to see statements, and on our right, you're going to see reasons. Okay, this is how I can really look into your thinking by writing proofs out. So every two-column proof starts with the given. Okay, so we always write the given down, and our reason is it's given to us. So angle 1 and angle 2 are vertical angles. It is given to us. Now from here, we want to think about how can we prove that these two angles are congruent. So our first step is, well, we know that angle 1 plus angle 3 is 180 degrees, and angle 2 plus angle 3 is 180 degrees, because these are supplementary angles, or you can call them a linear pair, right? A linear pair is linear pair theorem is another theorem that I had you look at last night, but they are supplementary angles. So therefore, the measure of angle 1 plus the measure of angle 3 is 180 degrees. Again, we're looking at numerical values, so we need to put a little m in the front. So it's the measure of angle 1. Then we can continue on. Well, according to the transitive property of equality, measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3, because both of these are 180 degrees. They're supplementary. All right? Then we can go ahead and subtract the measure of angle 3's from both sides. So if I subtract angle 3 over here and subtract angle 3 over here by the subtraction property of equality, then you have the measure of angle 1 is equal to the measure of angle 2. Now at this point, you might say, oh, we're done. No, we're not. This statement says the measure of angle 1 is equal to the measure of angle 2. But we're trying to prove that angle 1 is congruent to angle 2. So our last step is your last step should always be what you're trying to prove, which is angle 1 is congruent to angle 2. And the reason why we can go from step 4 to step 5 is because the definition of congruent angles, right? So because they're equal, they must be congruent. And that's just the definition of congruent angles. Okay. So this is your first little proof that you have seen. It's a two-column proof where you have your statements over here and your reasons for all of your statements over here. Okay. Here's another example. We're given that angle 1 and angle 2 are congruent, and we're trying to prove that angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. So essentially, we got to prove that all three of these angles are congruent. And here is the proof. So we have the given, and now we're able to use vertical angles because we are not trying to prove the vertical angles theorem. So angle 1 is congruent to angle 3 due to vertical angles, and angle 2 is congruent to angle 4 due to vertical angles. So therefore, if 1 is congruent to 2, and 1 is congruent to 3, and 2 is congruent to 4, then that means that 1 must be congruent to 2, which is congruent to 3, which is congruent to 4. Now, they call it the substitution property. You could also call it the transitive property, both of which would be true here. The substitution property and the transitive property are essentially interchangeable. In this example, we'll just, I like it. Let's move on. Sorry. Keep going. All right. The other theorem that we talked about is the congruent supplements theorem. I asked you to look at last night. And the congruent supplements theorem says if two angles are supplementary to congruent angles, then they are congruent. So what does that mean? If measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 3 plus the measure of angle 2 is also 180, then that means that the measure of angle 1 is congruent to the measure of angle 3. That's called the congruent supplements theorem. Okay, and again, so if two angles are supplementary to congruent angles, then they are congruent. So these angles are supplementary, these angles are supplementary, angle 2 is in both of these equations, so therefore angle 1 is congruent to angle 3. We can think of it as the same as the congruent complements theorem. The congruent complements theorem says if two angles are complementary to congruent angles, then they are congruent. So again, the measure of angle 1 plus the measure of angle 2 is equal to 90, and the measure of angle 3 and the measure of angle plus the measure of angle 2 is equal to 90, then that means that angle 1 must be congruent to angle 3. So we have a pair of complementary angles, another pair of complementary angles. We have an overlapping angle, which means our other two angles must be congruent. It's the congruent complements theorem. A couple of theorems that seem silly to write, but they're important because you're going to need them when you're writing your proofs. All right angles are congruent. Well, duh, because all right angles are 90 degrees. So another one of your reasons could be all right angles are congruent. Another theorem, again, that might seem intuitive but is important, is that if two angles are congruent and supplementary, then each is a right angle. So if angle 1 is congruent to angle 2, and the measure of angle 1 plus the measure of angle 2 is 180, then that means that angle 1 and angle 2 are right angles. And if they're right angles, well, then they're congruent because of the all right angles are congruent. And then we have the linear pairs theorem that I mentioned before. So the linear pairs theorem says that the sum of the measures of a linear pair is 180 degrees. So if angle 1 and angle 2 form a linear pair, like we see here, this is a linear pair where I have a line and then I have a ray, and the two angles separated by the ray add up to 180 degrees. They are a linear pair. And you can look at this diagram here, and I can move this around, and you can see that no matter where I put it, the two angles would add to 180 degrees. And they are a linear pair. Not every supplementary angle is a linear pair, but every linear pair is supplementary. That's important to know. Let's look at another example of a proof. It's going to be a little longer. Okay, so we're looking at a two-column proof. So we know that the measure of angle 1 is equal to the measure of angle 2. 1 and 2 are equal. and when the measure of angle 1 is 105 degrees. We're going to prove that the measure of angle 3 is 75 degrees. So first, we always start with our given. The measure of angle 1 is equal to measure of angle 2. And the measure of angle 1 to 105 degrees. Okay? Now, the measure of angle 2 is also 105 degrees. How do I know this? Well, the transitive property. Because the measure of angle 1 is equal to measure of angle 2, and we're given that measure of angle 1 is 105, so therefore the measure of angle 2 must also be 105. We also know that angle 2 and 3 are a linear pair because of the definition of a linear pair. Since they are a linear pair, they must be supplementary. So when you add them together, you get 180. That's the linear pairs theorem. Okay. I'm going to substitute in 105 degrees for angle 2. So I get 105 plus the measure of angle 3 is equal to 180. That's the substitution property of equality, because we are substituting in a value for angle 2. And then using subtraction, you get the measure of angle 3 is equal to 75 degrees. And we have officially completed our proof. Okay. Proofs are a little bit tricky. A little bit tricky for sure. And we're going to be focusing on proofs today. And you'll see I will post a handout that essentially gives you every possible reason for every statement that you will write. Okay, so keep an eye out for that. And we'll chat soon to go into more detail about proofs.